Hi, hello everyone. Welcome back to the Lokinath Lectures YouTube channel. So in this tutorial, we are going to discuss about algorithm analysis. So if you guys have a look at on this, so the algorithm analysis. So this concept we are going to explain with real-time example. So before going to the subject, please do subscribe Lokinath Lectures YouTube channel and don't forget to subscribe Lokinath Lectures YouTube channel. So the thing is like what is an algorithm analysis? So what is algorithm? So we previously discussed about what is mean by algorithm in a tutorial one. Like algorithm means like it's a step-by-step processor. These are all the things were discussed in the tutorial one. So this tutorial we are completely discussing about analysis, about algorithm, like algorithm analysis. So algorithm analysis is nothing but if we say in general terms, so how much the algorithm is efficiently useful while implementing into the coding. So if we are taking one algorithm, how much that algorithm is useful for us while implementing into the coding. So we need to find the and then we go for implementation. So if you guys are have a look at on this, algorithm analysis does not depend on any programming language and does not depend on compiler and does not depend on programming. So algorithm analysis is not depending on programming language and which language we are choosing and compiler and hardware, like which are the system we are using, the hardware parts. So it's not depending on programming or these are all the things. So it's completely focusing on the logical performance of the algorithm. It means like if we say, so algorithm is focusing on how much is efficiently is working, how much efficiently it's performing on the task. So we need to analyze. So first, why do we need algorithm analysis? Why do we need algorithm analysis? So algorithm analysis ఎందుకు చేయాలి? సో algorithm analysis ఎందుకు చేయాలి అంటే, so if we are required to choose the algorithm for one problem statement, we need to analyze the thing. We need to analyze that algorithm. Why? Because we need to choose the best one. We need to use the best one. So that's a requirement. We need to analyze the algorithm, then we go for implement into the coding. So for example, so we are having one problem statement. For that problem statement, we can write multiple algorithms. So the multiple algorithms. So few of the algorithms are more efficient in time complexity and few of the algorithms are more efficient in space complexity and few of the algorithms are enough enough less comparisons. So these are the things will be there in the algorithm analysis. So if you guys are observing here, why do we need algorithm analysis means, so we require to analyze the execution time, we need to analyze the memory uses, and we need to analyze the number of comparisons are required. So while applying one algorithm into one problem statement, we need to analyze. So this algorithm is able to complete within a given period of time, within a given period of time as well as within a memory space. So on so the number of comparisons. So few of the algorithms will take more comparisons and few of the algorithms will take less comparisons. So that's the reason we need to do the algorithm analysis. So by the doing of algorithm analysis, we can easily identify the most efficient algorithm. So we can easily identify most efficient algorithm. So this is the example one. So in the while starting the lecture, only I already told to you, like with the real-time example, we are going to discuss about algorithm analysis. So this is the problem statement. So we need to find the roll number 45 in a overall 64 students. So the 64 students are also roll numbers are also in a ascending order. So we need to find the 45 roll number. So for this problem statement, we are having two algorithms. So we can find that 45 roll number by using these two algorithms. One is linear search and another one is binary search. So by the using of these two algorithms, we can find that roll number 41. But which is more efficient? We need to analyze. So while completing this concept, this example algorithms, you can able to understand what's the requirement, what's the use of algorithm analysis. So the method one, linear search. So here, if you guys are observing, this is the linear search algorithm. So I hope you guys are already know about how to write an algorithm. So first we are writing start, and we are writing begin checking roll from roll number one, and we are comparing with each current roll number with the 45. If they match, we are stop it. So otherwise, move to the next roll number. So repeat this process until we found the matchable roll number. So this is the algorithm of linear search. So if you guys are observing, this is the execution, and we analyze the time complexity here. So how many comparisons here we required? How many times we are required to compare with one roll number to 45? So roll number 1, 45, roll number 2, 45, roll number 3, 45, roll number 4, 45. Like until we found the matchable roll number. So like 45 times we need to compare. Okay. So the number of comparisons means like the total comparisons we required, total 45 comparisons we require to analyze that roll number. So every student from roll number 1 to roll number 45, we must checked. Then we found that required roll number, rather roll number is 45. So the time complexity. So the time complexity is worst case. Worst case means like a big O notation. So big O notation means big O of n. So for n students, the worst case time complexity of linear search is big O of n. Here we required 45 comparisons. So this is the worst case scenario. So the worst case scenario is related to the big O notations. So this is the method to binary search. So in a binary search, we are having one condition. So what's the condition we are having in binary search? Binary search only works while the roll numbers are the data in a sorted order only. So here we're already the roll numbers in a sorted order. So we can easily apply this binary search. So here, if you guys are observing the binary search, so this is the algorithm. So here we can start the algorithm and find the middle roll number and compare the middle roll number with the 45. If equal, we are stop and terminating. If 45 is greater than, search the right of. If 45 is smaller than, search the left. So repeat until found. Then we are going to stop that process. So here, if you guys are observing the clear method to execution steps, so the binary search step by step. So I will explain in a simple and in a slowly. So please observe here. So here we are having overall the 5 comparisons. So first, the roll numbers 1 to 64. So 1 to 64, we are having the middle roll number is 32. Okay. So what's the rule here? Compare the compare the middle roll number with roll number 45. So 45 ని మిడిల్ రోల్ నెంబర్ తో కంపేర్ చేయాలి. సో మిడిల్ రోల్ నెంబర్ తో కంపేర్ చేసినప్పుడు ఏంటి, 45 ఈజ్ గ్రేటర్ దెన్ ఆఫ్ 32. సో 45 అనేది గ్రేటర్ దెన్ 32 అయినప్పుడు, సో వి గో ఫర్ సర్చ్ ఇన్ right off. So the left off we are ignoring. So we are not required to search in a left off. So we go for search in right off. So we search in roll number 30 to 64. Okay. While searching in roll number 33 and 64, the middle roll number, the next step. So the middle roll number is 48. So next we compare 45 with the 48. So while comparing 45 with the 48, so 45 is greater than of 45 is lesser than of 48. So it means we are ignoring right of and we are going to search in left of. So 33 to 47. So while searching in roll number 33 to 47, so the middle roll number. So what's the middle roll number here? So 40. So while comparing the 45 roll number with the 40, so the 45 is greater than of 40. So that's the reason we go for search in right of, and we go for ignore the left of. So while searching in roll number 41 to 47, so the middle roll number is 44. So we are comparing with the 44. So the 45 is greater than, and the left of we are ignoring, and we go for search in right of. So 45 and 47. So we go for one more comparison. So 45 compare with roll number 45. So in the fifth comparison, we are found that roll number. We are matched with the required roll number. So in a binary search, so what's the rule? We need to maintain the data in sorted order. So the first condition. And in a binary search, we just done only 5 comparisons while comparing to the linear search. In a linear search, we required 45 comparisons. In binary search, we found in 5 comparisons only. So what's the difference here? So the time complexity, the number of comparisons, the number of time complexity, the number of comparisons, and memory space. So these are all the things we need to observe here. So here the binary search is most efficient while comparing to the linear search. Why? Because we found that matchable roll number in 5 comparisons only. So here, if you guys are sorry, 6 comparisons. Here, if you guys are observing, so the total comparisons we require to found that required roll number is 6 comparisons. So what's the time complexity of binary search? Big O of log n. Big O of log n. So here, if you guys are observing, so here head to head means like linear search versus binary search. So here, if you guys are read these things, criteria, linear and binary things, so require sorted order. డేటా సార్టెడ్ ఆర్డర్లో ఇక్కడ లీనియర్ సెర్చ్లో అవసరం లేదు, బైనరీ సెర్చ్లో మ్యాండేటరీ. సో అప్రోచ్ చెక్ వన్ బై వన్. అండ్ బైనరీ సెర్చ్లో ఏంటి, ఆఫ్ ద ఎలిమెంట్స్ని మాత్రమే సెర్చ్ చేస్తాం, రిమైనింగ్ ఆఫ్ ఎలిమెంట్స్ని సో ఇగ్నోర్ చేస్తాం. ఎందుకంటే మనకి ఆ రోల్ నెంబర్ అనేది ఏ గ్రేటర్ దెన్లో ఉందా లెస్ దెన్లో ఉందా అని చెక్ చేస్తాం. సో గ్రేటర్ దెన్లో ఉన్నప్పుడు సో లెస్ దెన్ ద రిమైనింగ్ ఎలిమెంట్స్ వీఆర్ ఇగ్నోరింగ్. ఓకే. సో వర్స్ట్ కాస్ కంపారిజన్స్. సో 64 comparisons and 6 comparisons. So the time complexity. So big O of n, big O of log n. So this is all about like linear search and binary search comparisons. So by this example, so by the explaining this example, I hope you guys are able to understand the algorithm analysis. So here, if you guys are have a look at 2 resources. So every algorithm consume 2 resources. Complexity analysis helps determine how efficient an algorithm in terms of execution time and memory uses. So in terms of execution time and memory uses, we need to analyze how efficient an algorithm is useful for us while implementing into the programming. So time and space. టైం అండ్ స్పేస్. సో ఎంత ఫాస్ట్గా, ఎంత తక్కువ టైంలో మనకి టాస్క్ను పర్ఫామ్ చేయగలదు, ఎంత తక్కువ స్టోరేజ్లో, ఎంత తక్కువ స్పేస్లో మనకు టాస్క్ కంప్లీట్ అవ్వగలదు. ఐ మీన్ ద అవైలబుల్ రిసోర్సెస్. బై యూజింగ్ అవైలబుల్ రిసోర్సెస్, హౌ possible it will be able to complete the task, how much the possible, I mean how efficiently the algorithm perform the task in a available resources only like time and space. So the amount of execution time of an algorithm and the amount of memory required by an algorithm during execution. So these both things are most important in a algorithm. So in thanks for watching our videos, guys. Please do subscribe Lokinath Lectures and like and subscribe Lokinath Lectures. So in a tutorial 3, we are going to discuss about time and space complexity. And thank you so much. Please do subscribe.